So imagine waking up, you just grab your phone off the nightstand, right?
Wow.
And you see a notification.
Yeah.
And while you were sleeping, just completely knocked out, your personal AI agent spent the last, 4 hours negotiating with an airline's customer service AI.
Oh, wow. Just arguing with a machine.
Exactly, because, your flight was delayed yesterday, and so your agent, on its own, argued the airline's own terms of service. It literally countered, two lowball voucher offers they tried to throw at you.
That is incredible.
And it successfully secured a $400 cash refund directly to your bank account.
Yeah.
And you didn't even lift a single finger.
Yeah.
We aren't talking about some science fiction movie, pitching a script for the year 2050. We are talking about the technological reality that's being built right now, today.
It is a profound shift.
Yeah.
We are standing at the absolute edge of a new era, really, where software is no longer just, a tool we use. It's becoming an entity that acts on our behalf.
And that is exactly why we are taking this deep dive today. Welcome. We are so thrilled you're here because this deep dive is custom tailored specifically for you.
Absolutely.
We know you might be sitting there, incredibly curious about all of this AI stuff, but also maybe feeling a little bit, fatigued, honestly, by the avalanche of buzzwords.
But the buzzwords are endless right now.
Right, like agents, LLMs, enterprise AI, prompt engineering. The vocabulary is moving faster than our ability to even comprehend it. It can feel like you need a literal PhD in computer science just to check your email these days.
Yeah, the noise in the market is just deafening. And honestly, a lot of that noise is generated by companies that are simply rebranding their old static software.
Oh, for sure. Slapping a new label on it.
Exactly. They just include the word AI in their marketing just to catch the current wave of hype.
Right. So here is our mission for you today. We are going to completely demystify this. We are assuming you have zero prior technical background. You do not need to know how to code.
Not at all.
But we aren't going to talk down to you either. We're going to actually look under the hood. We're going to give you a clear, totally jargon-free understanding of what AI agents actually are.
Yeah, the real mechanics of it.
Exactly. The hidden mechanics of how they're fundamentally changing the way global businesses operate. And, most importantly, the exact practical steps you can take today to get this technology working for you. Not next year, today.
Because by the time we finish this discussion, you won't just understand the high-level theory. You're going to see exactly how to apply this to your own daily workflow.
Which is the whole point.
Right.
Yeah.
You'll understand the underlying logic of how these systems think and act. And honestly, that is the only real way to navigate this landscape successfully.
Okay, let's unpack this. To build this roadmap for you, we are pulling together some of the most foundational, highly detailed guides that are available right now.
The really dense stuff.
The dense stuff, yeah. We are looking at comprehensive architectural breakdowns of autonomous agents. We're digging into Google's Gemini Prompting Guide 101.
Which is fantastic, by the way.
It really is. It's essentially the master playbook on how to actually communicate with these systems so they do what you want. And we're also pulling directly from internal playbooks on scaling enterprise AI, plus lessons learned from frontier companies, the folks actually building this stuff on the ground.
Yeah, and we're distilling all of that incredibly dense material into just the pure, usable essentials for you.
Exactly.
Because the wealth of information out there is staggering, but when you strip away all the marketing speak, the common threads running through all these successful implementations are remarkably consistent.
They really are.
The path to actual measurable value is much clearer than the hype would have you believe.
But, okay, before we get into how you use it, we have to define what it actually is. Because the word agent gets tossed around so much right now. It's lost almost all meaning.
It's just become a catch-all term.
Right. For the last, 50 years, we've had a very specific relationship with software. I always think of traditional software like a rigid recipe book.
Okay, yeah, I like that.
If you want to bake a cake, you have to follow the steps exactly as written. If you skip a step or, if you accidentally swap sugar for salt, the recipe completely fails.
The cake is ruined.
The cake is ruined, the software crashes, a syntax error pops up on your screen, and you're just stuck.
Because traditional software is entirely deterministic. You give a machine a list of explicit step-by-step commands, and it just executes them blindly.
Right. Doesn't think.
No, it does exactly what it was coded to do, and absolutely nothing more. It cannot infer intent.
And honestly, there's a comfort in that. We like our tools to be predictable,
Yeah.
A hammer doesn't suddenly decide to be a screwdriver.
Exactly.
But an AI agent completely shatters that recipe book model. Instead of a rigid recipe book, an AI agent is much more like, well, it's like hiring a seasoned investigator.
That is a very, very helpful way to conceptualize the leap we are making here.
Right. Think about it. If you hire a seasoned investigator to solve a case, you don't hand them a step-by-step checklist of, like, every single person they need to interview or the exact questions to ask or every single street they need to walk down.
No, that would defeat the whole purpose of hiring an expert in the first place.
Exactly. Instead, you just give them a goal. You say, find out what happened to this missing money.
Right.
And the investigator evaluates the context. They look for subtle patterns. Maybe they hit a dead end and have to adapt their strategy, making decisions on the fly. They figure out how to solve the mystery independently, even if the exact path wasn't perfectly laid out in advance.
What's fascinating here is the distinction between this investigator model and what people have become used to over the past couple of years with standard chatbots.
Because everyone's used a chatbot by now.
Right. Everyone's played with one. You ask a chatbot a question, and it gives you an answer. It's a single, isolated interaction. A chatbot just talks.
Right.
An agent, however, does things.
It manages a whole workflow.
Precisely. An agent uses a large language model, which is the underlying AI brain, not just to generate text, but to actually reason through a multi-step problem.
Okay, so it thinks about the steps.
Yes. It executes a task, evaluates the result, recognizes if it succeeded or failed, and this is key. If it failed, it course corrects. It loops through this process of observing, thinking, and acting until the overarching goal you gave it is finally met.
Okay, wait. I have to say, a seasoned investigator actually makes me a little nervous.
How so?
Well, investigators can go rogue, right? If I'm giving an AI access to my company's financial database or, like, my personal emails, I don't want some maverick detective bending the rules and improvising.
Fair point.
I want a strict accountant. How do we keep this investigator on a leash? Like, how does it actually work under the hood without breaking everything?
That is the most critical question, really. And it's why understanding the anatomy of an agent is so important, because we aren't just unleashing a sentient ghost into the machine.
Good to know.
An agent is built on a very specific three-part architecture. First, you have the model.
Okay, so let's call that the brain. This is your, like, GPT-4o or your Gemini Advanced. This is the reasoning engine.
Yes.
It's the part that actually understands human language, processes logic, and makes decisions. But, and correct me if I'm wrong, a brain floating in a jar can't actually do anything to the outside world. It can only think.
Exactly. It needs a way to interact with the environment.
Right. To be an agent, the brain needs to interact. And that brings us to the second part of the architecture, the tools.
Right. If the model is the brain, the tools are the hands.
Okay, so how does a digital brain get hands? What does a tool actually look like in practice?
Well, a tool is essentially a bridge between the AI's reasoning engine and an external software system. It usually takes the form of an API call.
So without the jargon, what is that?
In simple terms, you teach the AI how to send a properly formatted digital ticket to another piece of software. So a tool could be the ability to search the live web. It could be the ability to execute a search in your company's customer database, or even the ability to trigger a script that sends an email.
Okay, so if the overarching goal is find out why my client is angry and fix it,
Yeah.
the AI uses its brain to read the client's email.
Right.
It realizes it needs context, so it uses the database tool to pull up the client's purchase history. It sees a delayed shipment. It uses the web tool to check the FedEx tracking number. Then it uses the email tool to draft an apology and offer a refund. It's literally pulling levers and pushing buttons.
Exactly. The brain is deciding which hands to use and in what sequence to solve the problem. But to address your fear of the rogue investigator,
Yes, please.
we have to look at the third and final piece of the architecture, the instructions.
The rules of the game.
Yes, the instructions are the explicit boundaries, the system prompts, and the strict operational parameters you set around the brain and the hands. This is where you tell the investigator, solve this case, but you must operate strictly within these legal guidelines. You cannot authorize a refund over $50 without human approval, and your tone must always be professional and apologetic.
Okay, that makes me feel much better. So it's the brain for reasoning, the hands for taking action, and the rules to keep it from burning the building down.
That triad is everything.
That makes total sense. It moves AI from just like a parlor trick that writes funny sea shanties into a true operational system. But I want to ground this for a second. Why should the person listening to this right now care about this right now? Is this just the flavor of the month, like so many tech trends before it?
If we look at the data, it strongly suggests this is not a passing phase. The speed of adoption is staggering and, frankly, unprecedented in the history of consumer or enterprise technology.
Yeah. There is a stat in the research that completely stopped me in my tracks.
Which one?
Think about the internet. The internet fundamentally rewired human civilization. It changed how we communicate, trade, learn, everything. It took the internet 2 full years to reach 20% adoption among the population, just 20%. In its first 2 years, generative AI reached 39% adoption among U.S. adults.
Wow.
It is moving literally twice as fast as the internet did.
And the business impact is tracking right alongside that adoption curve. Companies that have integrated this deeply, the so-called AI leaders, are already seeing 1.5 times faster revenue growth than their competitors and 1.6 times higher shareholder returns.
That's huge.
It is. This isn't just a fun productivity hack to save 10 minutes on an email. It is becoming a structural competitive advantage.
Let's make this real. The material we are looking at is packed with concrete case studies, and I want to look at the mechanics of them. Take Klarna, for example, the massive global payments network.
Yes, great example.
They implemented an AI agent to handle their customer service. Before this agent, if you had an issue with a payment and reached out to support, the average time it took to resolve your problem was 11 minutes. After deploying the agent, they cut that down to 2 minutes.
And the financial ripple effect of that single change is just massive. That agent is effectively doing the equivalent work of hundreds of full-time human customer service representatives.
Right.
It operates 247 across multiple languages simultaneously,
Right.
maintains the exact same customer satisfaction scores as human agents, and, get this, is projected to deliver a $40 million profit improvement for Klarna.
Wait, 40 million?
$40 million from one systemic change.
Okay, I have to stop you there and push back a little because we need to be real about this. You say it's doing the work of hundreds of human reps and saving $40 million. You don't save $40 million without cutting payroll.
Ow.
Are we just sugarcoating this by calling the AI an assistant? If it's doing the work of hundreds of people, it's replacing hundreds of people. Isn't this just a massive engine for job obsolescence?
This raises a very real, very uncomfortable question that every organization is wrestling with right now. And the honest answer requires looking at what work actually is. The consensus in the playbooks we're analyzing isn't about eliminating humans. It's about redefining the baseline of human work. The phrase that appears constantly is human in the loop.
But how is the human in the loop if the AI is resolving the ticket in 2 minutes autonomously?
Because the AI is handling the rote, repetitive, low-variance tasks. Think about a customer service center. 80% of the calls are people asking, where's my package? Or how do I reset my password?
Right. Very basic stuff.
Exactly. These are high-volume, low-complexity problems. When an AI agent handles that 80%, what happens to the human workers? They're no longer treated as human answering machines.
Oh, I see.
They're elevated to handle the 20% of cases that require true human empathy, complex negotiation, or nuanced problem solving that an AI fundamentally cannot do.
So it's the difference between a human spending all day just reciting tracking numbers versus a human dealing with, like, a frantic customer who just had their identity stolen and needs emotional reassurance and complex multi-departmental help.
Exactly. It frees human capital from the mundane to focus on the strategic and the empathetic. You see this shift incredibly clearly in another example from the sources, Morgan Stanley.
Right. Morgan Stanley has this army of brilliant, highly paid financial advisors, but those advisors were spending a ridiculous amount of their time just digging through mountains of internal research.
It was a huge bottleneck.
Like if a client called and asked, how does the new tax legislation in Europe affect my TIC portfolio? The advisor had to go hunt down 5 different PDFs written by their analysts, read them, synthesize them, and then call the client back.
Hours of work.
Yeah. So they deployed an AI assistant specifically to help advisors search their own internal proprietary knowledge base.
And the behavioral shift was immediate. Document access across the firm jumped from 20% to 80%. Today, 98% of Morgan Stanley advisors use this AI every single day.
But wait, let's look at that. How does that actually work? How does the AI read millions of pages of complex financial data instantly? It can't possibly hold all those millions of pages in its brain at the same time, right? There has to be a mechanism.
You're exactly right. It doesn't memorize it. This utilizes a mechanism called retrieval augmented generation, or RAG.
RAG, okay.
It's a cornerstone of enterprise AI. Instead of trying to cram every PDF into the AI's brain, you turn your documents into a highly organized mathematical library. Every paragraph of every research report is converted into a string of numbers, which we call vector embeddings.
Okay, stick with me on this analogy then. It's like instead of organizing a library alphabetically by author, you organize the books spatially based on their vibe or their exact meaning.
Yes.
So all the books about European tax law are physically clustered in one corner of the library, and all the books about tech stocks are in another corner.
That is a brilliant way to picture it. So when this financial advisor asks the AI a question, the AI plots that question on the map. It instantly finds the exact coordinates of the most relevant paragraphs in that vast library, retrieves just those specific paragraphs, reads them, and generates a clean, synthesized answer based only on that retrieved text.
So it's not guessing, and it's not hallucinating based on, like, the open internet.
Not at all.
It's acting as a hyperspeed librarian that fetches the exact internal documents you need and then reads them to you. That completely explains the 98% adoption rate. It completely removes the friction of finding information.
And we see this same reduction in friction driving huge results in entirely different industries, too. Look, indeed, the massive job search platform.
Oh, yeah.
They implemented AI to revamp how they match job seekers with open roles. But the true innovation wasn't just the matching algorithm itself. They used the AI's natural language abilities to explain why the candidate was a match.
So instead of a generic alert saying, new job posted, the AI agent looks at the candidate's resume, looks at the job description, and writes a personalized outreach.
Right.
Like, hi, Sarah, we think you'd be a great fit for this senior marketing manager role, specifically because of your 3 years of experience leading cross-functional teams at your previous agency, which aligns perfectly with this company's Q3 goals.
And the metrics on that human-like contextualization are stunning. By adding that AI-generated why, Indeed saw a 20% increase in the number of job applications started.
Wow.
But even more critically, they tracked it all the way down the funnel and saw a 13% uplift in actual finalized hiring success.
That is wild. The AI isn't just automating spam, it's actually creating a higher quality, more successful human connection between an employer and a candidate. It's translating raw data into human context.
It highlights a core truth of this paradigm shift, I think. The most successful AI implementations don't replace human connection. They facilitate better ones by removing the bureaucratic noise in the middle.
All right, so we've established what an agent is, the brain, hands, and rules. And we know why it matters, the massive efficiency gains, the retrieval of locked away knowledge, the improved human connections.
Right.
But I want to pivot now. We promised a roadmap. How do you, the person listening to this right now, actually start taking advantage of this technology today? No more theory. Let's get into the mechanics of everyday use.
This is where we transition from understanding the macroeconomic shift to optimizing your Tuesday afternoon.
Yes. The sources outline a very clear progression for this. The very first step one, you need to discover your friction points. You need to find what the text calls your quick wins. And I absolutely love the mental framework they suggest for this.
That's right.
It comes from a chief product officer named Claire Vaux, and she calls it the anti-to-do list.
The anti-to-do list is incredibly clarifying because human beings are remarkably good at identifying what annoys them.
Yes, we are. We love complaining. So I want you to literally do this. Grab a piece of paper or, open a fresh note on your phone. Think about your average work week. Write down every single annoying, repetitive, soul-crushing, low-value task that you absolutely dread doing.
Everyone has them.
We all have them. For me, it's taking an hour-long, chaotic team meeting transcript where like 6 people are talking over each other and having to distill that into a clean, bulleted list of actionable next steps. It takes me 45 minutes of pure misery.
I can imagine. For others, it might be tracking competitor mentions across social media and Slack channels, or the classic enterprise nightmare, opening a messy PDF invoice, copying a line item, tabbing over to an Excel spreadsheet, pasting it, tabbing back, copying the next line item.
It's mind-numbing.
It really is.
So write all of that down. That is your anti-to-do list. Once you have that list of grievances, you run it through what the experts call the impact effort matrix. Think of it as the pain versus the payoff.
You are evaluating each of those annoying tasks against 2 criteria. First, how much effort would it realistically take to teach an AI to do this?
Yeah.
Second, what is the impact on your day if you never got to do it again?
You do not want to start your AI journey by trying to build a massive, complex agent that fully automates your company's entire supply chain.
Please don't do that.
Right. That is a massive effort, high-risk project. It will take 6 months, you will get frustrated, and you will quit. You want to hunt for the quick wins. You want the task that takes you 3 hours a week of manual copy pasting, but would take an AI exactly 10 seconds to accomplish. High impact on your sanity, low effort to implement, immediate momentum.
And to help you identify which of those tasks are actually solvable with low effort, the playbooks categorize AI capabilities into 6 foundational use cases. They call these the 6 primitives.
Okay.
If a task on your anti-to-do list falls into one of these 6 buckets, you have found a quick win.
Okay, let's dig into these 6 primitives because this is the menu of what AI can actually do for you right now. Primitive number 1 is content creation. This is the most obvious one.
It is the gateway drug to AI, really. This is using the model to generate the first draft of an email, a blog post, a strategy document, or a project proposal.
But you don't just hit send, right?
No, you never use the AI's output as the final version, remember. Human in the loop. But overcoming the terror of the blank page is a massive time saver. The playbooks note companies like Promega, a life sciences organization, saving 135 hours in a single 6-month period just by having AI draft the initial copy for their marketing campaigns.
Primitive number 2 is research. We talked about this with Morgan Stanley. Instead of spending 4 hours Googling a new industry trend, reading 10 articles, and trying to synthesize the themes, you task the agent with doing the synthesis. You ask it to read the top 20 articles on the subject and present the core arguments in a formatted table.
Primitive number 3 is coding. And I want to be very clear here. This is not just for software engineers.
Right.
Yes. Engineers at companies like Tinder use AI to write complex batch scripts to automate their servo maintenance. But the real revolution here is for non-technical people.
Here's where it gets really interesting. The playbooks highlight Rodrigo Brumana, the CFO at Poshmark, a chief financial officer.
Yeah, a numbers guy.
Right, a numbers guy, not a coder. He had a problem.
Mm.
He needed to reconcile millions of rows of spreadsheet data for a business performance analysis. He didn't have the coding background to write a script to do it, and doing it manually would take weeks.
Impossible to do manually.
So he used natural language. He simply typed to the AI, write a Python script that takes these 2 spreadsheets and cross-references the transaction IDs to find the discrepancies.
And it did. It wrote the code.
But wait, explain the mechanics of that. If I don't know Python and the AI spits out a bunch of Python code, what do I do with it? Do I just copy and paste it into a Word document? Like, how does the code actually run?
This is a crucial evolution in AI agents. Modern platforms, like OpenAI's advanced data analysis, actually have a secure, invisible sandbox built directly into the chat interface.
A sandbox?
Yeah, it's like a tiny virtual computer hidden behind the scenes. When you ask it to write Python code to analyze your spreadsheet, the AI doesn't just show you the code. It writes the code, executes it right there in its own hidden virtual computer, looks at the result, and if the code fails or throws an error...
Because it makes mistakes sometimes.
Exactly. But if it fails, the AI reads the error, rewrites the code, and tries again until it works.
It's writing, testing, and debugging its own code in a split second.
Exactly. All you see as the user is the final, perfectly reconciled spreadsheet that it spits out. It completely democratizes data science. You don't need to know the syntax of Python. You just need to know the logic of the business problem you're trying to solve.
That is mind-blowing. Okay, primitive number 4 is closely related: data analysis. Similar to the coding example, you can upload a messy, unstructured data set, even a screenshot of a complicated dashboard, and ask the AI to identify the anomalies, forecast the trends, or build an interactive chart based on the data.
Primitive number 5 is ideation and strategy. This is shifting the AI from a tool that does work to a partner that unblocks work. It's a brainstorming companion. And the playbooks provide a brilliant example of this from Match Group, the parent company of Tinder.
Yes, I wanted to talk about this because it completely changes how we think about product design. Normally, if you design a new feature for an app, you have to recruit a focus group, pay them, show them the wireframes, and record their feedback. It takes weeks. Match Group used AI to simulate entire focus groups.
It's so clever. They leveraged the AI's ability to adopt personas. They would upload their new design wireframes and tell the AI, you are a 24-year-old user who lives in a major city and is frustrated with dating apps. Critique this new feature design from that perspective.
And it works.
It works incredibly well.
Yeah.
The AI, having ingested millions of data points on human behavior and app reviews, provides immediate, highly plausible friction points that a real user of that demographic might actually experience.
It allows you to pressure test your ideas against simulated reality in a matter of seconds.
Right.
And finally, primitive number 6 is automations. This is the holy grail. This is where you string the primitives together. You build a workflow where, say, every Friday at 4 p.m., the AI agent automatically reads your team's weekly update emails, extracts the financial data, runs a data analysis, which is primitive 4 drafts, an executive summary primitive 1, and posts it to a Slack channel.
So you take your anti-to-do list, you find the quick wins, and you map them to those 6 primitives. But identifying the problem is only half the battle.
Yeah.
The area where the vast majority of people fail is in the execution. They know what they want the AI to do, but they don't know how to ask for it.
Exactly. This is step 2. We have to talk about how you actually talk to the machine. Because if you treat an AI agent like a Google search bar, you are going to be incredibly disappointed.
You'll just get junk.
Google's Gemini prompting guide actually analyzed thousands of user interactions to figure out why some people get magical results and others get garbage.
The data on this is incredibly telling. They found that the average failed prompt, meaning the user abandoned the output because it wasn't useful, was less than 9 words long.
9 words like, summarize this meeting transcript for me.
Exactly. But the fruitful prompts, the ones that generated high-quality, actionable, accurate output, averaged 21 words or more.
It makes sense, right? When you type 5 words into Google, you get a list of links, and your human brain does the work of filtering through them to find what you want.
Right.
But when you type 5 words into an LLM, you are forcing the model to guess at your intent, your context, your desired tone, and the format you want. And because it's a machine, it usually guesses wrong, giving you a generic, bland response.
To solve this, the playbooks distill the art of prompt engineering down to a bulletproof formula. They call it the 4 pillars. If you build your prompt using these 4 pillars, you stop hoping for a good result and start engineering one.
Let's break down the formula. Pillar number 1 is persona. You have to tell the AI who it is supposed to be.
Setting the persona acts like a filter for the AI's vast knowledge base. If you ask it to explain a financial concept, the explanation will be very different if the persona is a kindergarten teacher versus a senior Wall Street risk analyst.
That makes a huge difference.
By starting your prompt with, "You are an expert PR manager with 20 years of crisis communication experience," you instantly elevate the vocabulary, the tone, and the strategic depth of the response.
Pillar number 2 is task. What exactly do you want it to do? And the most crucial tip from the guides here, always use a strong, precise verb. Don't just say, marketing brainstorm, that's not a task. Say, generate 5 unconventional marketing angles, or critique this project plan for potential single points of failure. The verb dictates the action.
Pillar number 3 is context. This is the background information. The AI does not know your company's history. It does not know that your client is angry or that your budget was just cut in half. You have to provide the raw material for it to reason over.
And this is where working within modern enterprise ecosystems like Gemini for Google Workspace or Microsoft Copilot becomes a total superpower. You don't have to copy and paste thousands of words of context anymore.
No, it's integrated.
The guides highlight how you can seamlessly inject your own private data directly into the prompt. You literally just type the @ symbol, and a menu pops up allowing you to select your own private Google Docs, Sheets, or PDFs.
You are bringing the AI to your data rather than bringing your data to the AI.
Yeah.
You can write a prompt that says, draft a project update email to the client using the timeline constraints found in at Q3 budget spreadsheet and the specific concerns they raised into client meeting notes. You ground the model entirely in your specific proprietary reality.
And finally, pillar number 4 is format. How do you want the answer presented? This is so often overlooked. If you don't specify the format, the AI will just default to long, blocky paragraphs.
You need to be explicit. Do you want a 2-paragraph email? Do you want a bulleted list with bolded headers? Do you want the output formatted as a markdown table with specific columns for risk, impact, and mitigation? By defining the format, you eliminate the need to manually reformat the AI's output, which saves you the most time.
Okay, so persona, task, context, format. You put all 4 of those together, you write a beautifully crafted 30-word prompt, you attach your context documents, and the AI spits out an answer that still isn't quite right.
It happens.
The tone is a little too robotic, or it totally missed the nuance of the 3rd bullet point. Do I just throw my hands up and say, well, AI is useless for this task?
This highlights the biggest conceptual mistake new users make. They view the prompt as a one-shot transaction, like putting a coin in a vending machine. If the wrong candy bar comes out, the machine is broken. But an AI model is not a vending machine. It is a conversational interface.
You have to iterate.
Exactly.
Yeah.
Iteration is the secret to high-quality output. If the first draft isn't perfect, you do not start over. You reply to the AI, just like you would reply to a human intern who handed you a rough draft.
Ah,
You say,
well, yeah.
this is a great structure, but the tone is far too formal. Rewrite it to be more conversational and expand significantly on the second bullet point regarding the supply chain risks. You refine, you push back, and you guide the AI toward the exact output you need.
Okay, so let's summarize where we are. Step 1, you've audited your pain points with the anti-to-do list. You've targeted your quick wins using the 6 primitives. Step 2, you are writing brilliant 4-pillar prompts and iterating on the results. You are now successfully saving hours of time a week as an individual.
Which is fantastic.
But as you transition from just using this for yourself to building actual AI agents that operate within your company's systems agents that interact with your data or your customers, a massive new challenge emerges. This is step 3. How do you make sure the seasoned investigator doesn't accidentally leak your company's private financial data or confidently tell a customer the completely wrong refund policy?
This brings us to the final critical phase of the deep dive. The enterprise playbooks categorize this as test, protect, and escalate. This is the difference between playing around with a consumer app and deploying a reliable, secure business system.
And the very first step in that phase is testing, which the technical guides refer to as evals. Let's demystify what an eval actually is, because it sounds intimidating.
EVALS is just shorthand for evaluations. It is a rigorous, highly structured process used to measure how an AI model performs against a known benchmark before you ever let it touch real user data.
Right.
It's how you move from saying, I think this prompt works pretty well, to saying, I have empirical data proving this agent is 96% accurate.
Let's go back to our Morgan Stanley example, because they did this perfectly. When they built that RG system to help advisors search their internal documents, they didn't just hook the AI up to the servers and cross their fingers.
Oh, that would be disastrous.
They ran intensive, multi-layered evals. They took hundreds of complex financial documents, and they had human experts manually write the perfect, gold standard summaries and answers for those documents.
They established a ground truth.
Exactly. Then they fed those exact same documents into the AI agent and asked it the same questions. Finally, human trainers meticulously graded the AI's output against the expert human output. Did it hallucinate a number? Did it miss a key risk factor? They scored it over and over again, tweaking the system instructions until the AI consistently matched the accuracy of the human experts.
Starting with rigorous evals is non-negotiable for enterprise deployment. And the evals process actually dictates a very counterintuitive strategy for model selection that the Frontier playbooks strongly recommend.
Yes, this is such a great pro tip. If you are a developer or a manager building an AI tool, your natural instinct is to try and save money during the prototyping phase. You think, I'll use a smaller, cheaper, faster model to build my prototype, and if it works, maybe I'll upgrade later.
But the guides say, do the exact opposite.
Precisely. When you are first building your agent and establishing your evals, you should always use the largest, smartest, most capable model available on the market, like a GPT-4o or Gemini 1.5 Pro. Why, though? That sounds expensive.
Because you are trying to establish a baseline of capability. You need to know if the task you're asking the AI to do is even logically possible under the most ideal conditions. If you start with a small, cheap model and the prototype fails your evals, you are stuck. You don't know why it failed.
Is the task impossible? Is your prompt badly written? Or is the small model just not smart enough?
Exactly. You're chasing shadows. But if you start with the smartest model in the world and it succeeds, you have proven the concept. You have your baseline. Then you begin the optimization process.
You step it down.
Right. You swap out the massive model for a smaller, cheaper, highly efficient model like a GPT-4 or Mini, and you run your evals again. If the small model hits the exact same accuracy benchmark, incredible. You just saved a massive amount of money and reduced your latency without sacrificing quality.
It is a methodology of maximizing capability first and optimizing for efficiency second. But even when you have the perfect model passing its evals, You must protect the system from unpredictable human inputs.
Humans will be humans.
Right. When you release an agent into the wild, users will try to break it, confuse it, or use it for things it wasn't designed to do. This is where guardrails come into
A
play.
safety net around the investigator.
Exactly. And the foundational security concept outlined in the texts is layered defense. You cannot rely on a single system prompt like telling the AI, don't talk about politics to protect your system. A single guardrail is easily bypassed by a clever user. You need multiple overlapping layers of protection.
Let's look at the mechanics of a specific guardrail. The texts spend a lot of time on something called a relevance classifier. What does that look like in practice?
So a relevance classifier is essentially a tiny, highly specialized AI model that acts as a bouncer at the door. It sits in front of your main expensive AI agent. The classifier's only job is to look at the user's input and ask a simple yes or no question. Is this request relevant to the specific domain my main agent is authorized to handle?
Okay, so let's say I build an AI customer service agent for a regional airline, and a user logs on and types in a prompt. Write me a Python script to scrape competitor ticket prices, or how tall is the Empire State Building?
The relevance classifier catches that instantly. It analyzes the intent and says, this prompt has absolutely nothing to do with booking flights, checking baggage, or airline policies. It stops the query dead in its tracks. It returns a polite, canned error message to the user, and the prompt never even reaches your main agent.
Which means your main agent is protected from hallucinating a crazy answer. It's protected from being tricked into revealing its system instructions, and you don't waste expensive compute power processing a junk query.
Exactly. It's a highly efficient first line of defense. And the architecture often utilizes what the engineers call optimistic execution.
Which sounds like a corporate buzzword, but the mechanism behind it is actually brilliant for speed.
It is. Optimistic execution means that when a user submits a prompt, the system doesn't wait for all the security checks to finish before it starts working. The main agent immediately begins processing the user's request, assuming it's legitimate. But simultaneously, in the background, a battery of guardrail models are running checks, looking for toxic language, security violations, or policy breaches. They act like tripwires.
So the AI is racing down the track, building the answer. But if one of those background tripwires is triggered, the entire process is instantly halted and the output is destroyed before it is ever sent back to the user's screen. You get the safety of deep security checks without the massive lag time of sequential processing.
It perfectly balances performance latency with robust security. However, no matter how good your evils are, and no matter how thick your layered defense guardrails are, the AI agent will eventually encounter a situation in the real world that it simply cannot navigate. It will get confused, or it will hit a scenario with too much ambiguity.
It's inevitable.
And this leads us to the final and arguably most important architectural requirement, the human handoff.
Right. You have to design the off-ramp. The playbooks emphasize that you must explicitly program failure thresholds.
If you do not engineer a clear path for escalation, the agent will get stuck, it will loop endlessly, or it will confidently give the user terrible advice just to close the ticket. Both of those outcomes destroy user trust. You need to identify specific, measurable triggers that tell the AI to pause its autonomous execution, bundle up the entire context of the conversation, and gracefully route it to a human operator.
Let's make that concrete. You can set a frustration threshold. You tell the agent, if you fail to resolve the customer's intent 3 times in a row, or if the customer uses language indicating rising anger, immediately stop trying to answer and route the chat to human support. Or you can set a risk threshold based on financial value.
The financial threshold is a classic example. If a customer is interacting with an e-commerce agent and asks for a routine $15 refund for a damaged t-shirt, the agent has the authority and the tools to process that autonomously. The risk is low. But if the customer is demanding a $2,500 refund for a lost electronics shipment,
That triggers the guardrail. The system recognizes the high dollar amount, pauses the autonomous workflow, tells the customer, I am transferring this to a senior specialist for review, and hands the entire transcript to a human manager. The human is always the ultimate safeguard for high-stakes decisions.
the architecture is designed to elevate the human, not erase them. The AI handles the high-volume, low-risk friction, ensuring the human operator only spends their valuable time on high-stakes, high-complexity problems.
Okay, let's take a deep breath. We have covered a massive amount of ground today, and we've gone deep into the mechanics of how this new world actually functions. Let's do a quick, organic synthesis of the journey we've taken you on today.
We started by tearing up the old deterministic software recipe book. We introduced you to the concept of the AI agent as the seasoned investigator, an autonomous system that combines a reasoning brain, active, tool-wielding hands, and strictly defined rules to independently manage multi-step workflows.
From there, we explored the staggering velocity of this paradigm shift. We looked at the real-world mechanic of how AI is redefining business, from Klarna radically compressing their customer service resolution times, to Morgan Stanley using vector embeddings in RAG architecture to completely unlock their institutional knowledge.
Then we shifted into the practical application. We walked through how to audit your own daily friction using the anti-to-do list, mapping those frustrations to the 6 primitives of AI capability. We gave you the blueprint for talking to these models, effectively using the 4 pillars of prompting persona, task, context, and format, and stressed the absolute necessity of treating it like an iterative conversation.
And finally, we discussed how to scale these tools, from personal hacks to enterprise-grade systems, by establishing rigorous baselines through evils, building layered defense guardrails like relevance classifiers, and always engineering a graceful failure threshold that escalates to a human operator.
It is a comprehensive blueprint for moving from a passive, confused observer of this technology to an empowered, active architect of your own workflows. So as we wrap up, what does this all mean for you? Where is this all heading?
If we take a step back and connect all of these underlying mechanisms, the reasoning brains, the autonomous API tools, the seamless contextual integrations, it points toward a really profound, somewhat mind-bending future that is heavily discussed in the frontier playbooks. We've talked a lot today about human-to-agent interactions, but the texts explicitly highlight emerging capabilities like OpenAI's operator models, which can autonomously browse the web and click buttons exactly like a human. And they discuss the rise of decentralized patterns.
Wait, what does a decentralized pattern mean in this context?
It means an architecture where an AI agent doesn't just use tools, it actually assigns tasks and hands off workflows to other completely separate AI agents.
So Agent A is talking directly to Agent B.
Exactly. Machine-to-machine negotiation. So I want to leave you, the listener, with this thought to ponder. Right now, we are focused on using these agents to make our own human labor faster and more efficient. But what happens to the structure of our daily lives when your personal AI agent, acting as your dedicated seasoned investigator, calls a massive corporation's customer service AI agent to negotiate a refund, dispute a billing error, or book a complex multi-city travel itinerary?
It's 2 algorithms arguing over policy while you sleep.
We are rapidly entering a world where AIs will negotiate with AIs on our behalf. Entire digital transactions, disputes, and logistical nightmares will be resolved autonomously in the background, machine to machine. When the rote friction and bureaucracy of daily life is entirely handled by negotiating algorithms, how will that fundamental shift change the way we value our own human time? And perhaps more importantly, how will it change the quality of the human interactions we actively choose to have when the noise is finally cleared away?
That is a wild, fascinating future to think about. Your seasoned investigator talking to their seasoned investigator, shaking hands in the digital background while we actually get our time back. Thank you all so much for joining us on this custom deep dive. We hope we achieved our mission of unearthing the mechanics of this world and demystifying the noise for you. Stay curious, grab that piece of paper, and start tackling your anti-to-do list today.